Subscribe now and press the bell icon. Never miss an update.
Hello friends, welcome to my channel Engineering Media. You are watching Engineering Media. If you are new to this channel, please click the subscribe button and also click the bell icon. It will help me a lot, so you never miss any new updates. Today we are going to discuss about software engineering. What is meant by software engineering? Software engineering is the process of analyzing user needs and designing, constructing, and testing end-user applications that will satisfy these needs through the use of software programming languages. It is the application of engineering principles to software development. What does a software engineer do? As a software engineer, you are responsible for designing, developing and maintaining software systems including operating systems, business applications, mobile and web applications, games, connected hardware devices, networking systems and more. What are the three types of software? The three types of computer softwares are system software, programming software and application software. System software or operating system is the software used by the computer to translate inputs from various sources into a language which a machine can understand. Basically, the OS coordinates the different hardware components of a computer. There are many OS in the market. The most popular OS are from the stable of Microsoft. We have all heard, used and wondered at the Windows software, which is an OS. Starting with Windows, Microsoft has migrated to Vista, its latest offering in the market. It may come as a surprise to some that there are other operating systems used by others. Application software. A normal user rarely gets to see the operating system or to work with it. But all of us are familiar with application software which we must use to interact with a computer. Popular examples of application software are the Microsoft Office suite, which includes Word, Excel and PowerPoint. We have used these applications extensively. Internet Explorer, Mozilla Firefox is two applications used to access the Internet. Email software like Outlook Express is used to manage emails. It is obvious that all software utilized for working on a computer is classified as application software. In fact, all user interfaces are an application. The antivirus is an application and so is the media player. Programming software is the software which helps the programmer in developing other software. Compilers, assemblers, debuggers, interpreters etc. Integrated development environments, IDEs, are combinations of all these software. Programming software is also known as programming tool or software development tool. Software engineering. 7 principles of software testing. Software testing is a process of executing a program with the aim of finding the error. To make our software perform well, it should be error-free. If testing is done successfully, it will remove all the errors from the software. There are 7 principles in software testing. Testing shows presence of defects. Exhaustive testing is not possible. Early testing. Defect clustering. Pesticide paradox. Testing is context dependent. Absence of errors fallacy. Testing shows presence of defects. The goal of software testing is to make the software fail. Software testing reduces the presence of defects. Software testing talks about the presence of defects and doesn't talk about the absence of defects. Software testing can ensure that defects are present, but it cannot prove that software is defects-free. Even multiple testing can never ensure that software is 100% bug-free. Testing can reduce the number of defects but not removes all defects. Exhaustive testing is not possible. It is the process of testing the functionality of a software in all possible inputs, valid or invalid, and preconditions is known as exhaustive testing. Exhaustive testing is impossible means the software can never test at every test cases. It can test only some test cases and assume that software is correct and it will produce the correct output in every test cases. If the software will test every test cases, then it will take more cost, effort, etc., and which is impractical. Early testing. To find the defect in the software, early test activity shall be started. The defect detected in early phases of SDLC will very less expensive. For better performance of software testing will start at initial phase, that is, testing will perform at the requirement analysis phase. Defect clustering. In a project, a small number of the module can contain most of the defects. Pareto principle to software testing state that 80% of software defect comes from 20% of modules. Pesticide paradox. Repeating the same test cases again and again will not find new bugs. So it is necessary to review the test cases and add or update test cases to find new bugs. Testing is context dependent. Testing approach depends on context of software developed. Different types of software need to perform different types of testing. For example, the testing of the e-commerce site is different from the testing of the Android application. Absence of errors fallacy. If a built software is 99% bug-free but it does not follow the user requirement, then it is unusable. It is not only necessary that software is 99% bug-free, but it also mandatory to fulfill all the customer requirements. Software design levels. Software design yields 3 levels of results. Architectural design. The architectural design is the highest abstract version of the system. It identifies the software as a system with many components interacting with each other. At this level, the designers get the idea of proposed solution domain. High-level design. The high-level design breaks the single-entity multiple-component concept of architectural design into less abstracted view of subsystems and modules and depicts their interaction with each other. High-level design focuses on how the system along with all of its components can be implemented in forms of modules. It recognizes modular structure of each subsystem and their relation and interaction among each other. Detailed design. Detailed design deals with the implementation part of what is seen as a system and its subsystems in the previous two designs. It is more detailed towards modules and their implementations. It defines logical structure of each module and their interfaces to communicate with other modules. Thus we are come to the end of this session. For more updates, kindly subscribe my channel. If you have any suggestions regarding my channel, kindly comment in the comment section. You can also request your searching contents, that I can make that in my next video.